开始了。Position. Maybe. Okay. Oh, I should name this live stream studying because I'm just studying. It should be right. What? Bonus question. Mama, 你来看。啊，你在看啊？DGBC. Just say it was. Instantaneous velocity. You're not computing against me. So average velocity is just change displacement, change time. This should be the same. Instantaneous. Okay, slope. What? The motion below represents the motion of a dog. Oh. -4 velocity 1. Wait, what is the formula for this? XF. Don't ask me about graphs. Wait. Okay, what was for it? Maybe. Honestly, I'm not great at graphs. A robin's flying back and forth. Hold on. Just a second. Robin's flying back and forth. Its velocity v as a function of time t is given. What is the robin's displacement from 0 to 1.5? Displacement is area, right? Oh, God. So that's 1. and that's... No, come on, this is freest ones. You gotta be kidding me right now. Since 1.5. That's not right. No. Displacements. Unless it's 3 4.5. 3 times 4.5. Oh, wait. Almost there. 2.25. Yeah, no idea. I did find an error. Are you kidding me? Oh, it's negative. Oh, come on now. Alright. Ugh. 0.75. Negative. This time it's negative. So that's one. So from here to here, it's negative 5 times 1. So that would be negative 5. This one, it's 1 times negative 5 is negative 10, so negative 2.5. So negative 7.5. Is this the bonus question? No, it's question 4. Same position as t equals 0. What? Unless it's 5. So it'll be 5, and that'll be here. It's 4.5. I don't think that's... no. No. Come on now. 4.5 here. 2? No. Bro. Oh, so that was 5 and 2, that's 5. And from here to here, it's 5. Oh. No, I got the right idea. Yeah, it sucks. Let's try again. How to... What if it's green screen? Oh, no. Screen share? Peanut's flying back and forth. From 0 to 3 seconds. I'm not gonna get strong yet. 5 times 0 is 10, so this one's 5. And from here to here, it's 1 times 5, which is negative 2.5. No, positive 2.5. Oh my god. Positive 2.5. Okay. 2 times 4 is 8, and this is 4, and this one is 1 times 4. So 2 times 4 is 4, 2 times 1 times. No, but this one's. Oh, but that's 2, so. Please give me a 2 to 3. Negative. I'm just gonna put that. Alright. That's y negative 5, so negative 2.5. Alright. Constant velocity. Is this negative? No. Constant velocity, it should be right, so it should be this. Are you kidding? Alright, no, it's not wrong. Deceleration's 2. So change velocity over change time. Why? You just gave me this question. Okay, velocity is going down, so it should be here. Should always be here. A. Okay, so if acceleration's here, that means velocity should be constantly here, but it should not start at 0, so that's not right. Nope. Okay. Should be going down. This one. It says it starts at rest. Oh, it does say that. Oh. Okay. Okay, graphs. Okay. Acceleration, so it should be like that and does not start at 0. Bum bum bum. Which is none of them. What? No, it's not that one. But that didn't start at 0. Okay, well. That one just says acceleration should be 0. Okay. So that should be constant going down, so it should be something like that. It says it does not start at 0, so it should go. Now, okay, hold on a second. It is. I'm not scared. No one says not 6. I'm pretty. take for it. Oh god. Object moving at 2.3 meters per second. Squared. Accelerating. Take to reach 100 meters. Sure. Naughty. Shipping box is released from us at the top of a low function ramp. The ramp is marked at points. The bottom of the ramp is 5 meters from top of the ramp. It should be faster, right? Should be faster. E squared equals 2ax. Square root of e squared equals 2ax. Well, let me just go back. Where did my thing go? Oh my god, I can't push this. Oh my goodness. I think something's broken. Ugh. Alright. Yeah, I didn't find it. It's okay. Sellers on a highway on ramp. At the end of the on ramp, at a position of 4x. I don't know. 4x. So 4 equals ends up there. How did I? Maybe it's second. Position x 10 10 x equals 0 divided by x. So that's equals 2. Acceleration is nominal. They don't tell me. Constant acceleration. So that's 4. That's 4. So I don't know. Let's find. Oh, I don't know. 13, 14, 15, 16, 17, 18, 19, 20. What the heck? Bro, what is this? T1 equals square root of 2x over a. Physics teacher challenges his science to determine acceleration with which cars typically take off into traffic light and find their school. To collect data, the teacher enlists the help of a local police officer near the radar or your gun. Each time the stop line turns green, the student starts a stopwatch to measure the elapsed time t. Police officer takes readings of the furnace car's magnitude of velocity v every 2 seconds. Which quantity should each student plot to create a linear graph in which each analyzed car's acceleration can be determined? As a function cars every 2 seconds. So you every 2 seconds. What's every 2 seconds? So when it's here, it's 4, it's 7, it's 10. No, it should be top. No, it's velocity. What is the acceleration of the hippo? That's what they ask. Assume the hippo runs in a straight line. Okay. So change in velocity over change in time. And they don't give us change in time, so let's do change in time t. Acceleration is velocity over time. But velocity is change in position over change in time. So this is already a over t. Velocity equals change in position over change in time. And that is position. So x squared over x. So that equals x t times divided by t, which they don't give us. Okay. 40 times. Shout out. Oh, okay. Shout out to Cassie. Or Casey. Mm. 20. 40s, 20. B should be is from top to bottom. Oh, so it should be less. Should be less. I don't know which one would be. 80. So this is about position, so it should be that one. That one has time in it, so it should be that one. That one's 80, so that's 4 times as much. But 2, so 8, 2. No, it's just 2. That's 8, 2, 4. This one is 2, 4, 2. Don't know. Yes! Got it. Okay. Can't believe it. Alright, anyways. Sec? Oh, okay. That's not exactly how I solved it. Close enough. I didn't even use the right formula. Why would it not have time in it? You're asking me for the time. Oh no, they weren't. Oh, they were late. They were late for the speed. Oh. Okay, well. The right answer is the right answer, anyways. Initially, starting moment of race starts, the driver presses acceleration to achieve maximum acceleration. The car travels 5 meters in time A. How far would the car be down the track at time 3A? So it has to have time in it. Time in it. What's the difference between this? Okay, displacement. Okay, so it has to be this one. Let me take out my so 5 meters times 3A. So this one would be 3 equals velocity time initial velocity, so that's 0. 1/2 AT squared and T. Okay, this is 5. How far will the car? Oh, is it okay? Uniform. Okay, that's not too bad. So 1 equals 1/2. Oh, God. A and then 1 squared. And you're saying that it's gonna no, that's 5. So it says how far would it be at 3 squared? Okay, that's 10 equals 10. So acceleration equals 10. So 5, 3 squared equals 45. Which I don't think is right. Okay, it is right. Okay, it is right. Okay. Okay. Let's see. Students is asked to determine acceleration of a low friction cart as it rolls down an incline. Place the cart from rest at position 0. The cart rolls down movable photo gates. Students think of it. Are you also taking it? I'm like stressed. Good luck. Oh, sorry. Oh, oops. Mm. But that's squared. Yeah. Oops. Initial is 400 plus 2a displacement's 50. It's 800 equals 2a 50. So that's 16. And 8. No, that's what did it, no, it can't be 8. Okay, that is 8. Shipping box release. Velocity speed at the bottom of the ramp compared with the speed at the top of the ramp. Oh, didn't we have that question already? Oh, yeah. Okay. So they used the last one. So velocity squared. Oh, so that, but acceleration is 0. No, it's not 0. Oh, at least in rest. So v squared equals 2a. Okay, it's 1.25. This one is 2a 5. Oh. Oops. Oh. What was the question? Oh. So it's 2.5. But that's the square root of it. Bottom. Oh yeah, bottom should be faster. Where is the square root symbol? 2.5. Okay, that's what? That's not. It doesn't work. Oh. Okay. 10. Had to put in parentheses. 3. So that's around. It's around 2 times as fast. Yeah. Yes. You know what? Maybe I actually understand it. Or maybe not, I don't know. Alright. Next one. A helicopter. Let's see. C5, 100 meters. Initially at rest, so that means only 1/2 const. Oh, they give us the acceleration. Wow, that's so nice. Alright. I really need a calculator. Hold on a second. Okay, well, already. Right, so it should be 9.3. 9.3. Alright. An object is moving in one dimension. Position the object acts as a function of time is modeled mathematically by the equation x equals. Which of the following statements accurately describes the okay, so acceleration is this one, velocity is this one, and displacement is this one. Acceleration is not 0. Velocity is this one. Oh, but oh wait. Is it what? But that's true. What? Object speed is decreasing. I'll go with this. No. Great. Oh my god. How's it wrong? In the kinematic equation, x equals x. Average velocity is not. Oh. Okay. Constant tell us the initial position. The sign of the t term. Since they have the same sign, this object's speed is increasing. Oh. Oh. A shopping cart is rolling down a ramp at an initial velocity of 1 meter per second. Now its concentration of 3 meters per second squared. Okay. Yep, totally. So as velocity and time, if it's velocity and time, it should be in the first one. Initial velocity. Oh, okay. Oh, this one's just about direction. Okay, so it should be going. It should be increasing. Positive or negative? Oh my god. How is it possible? It's going down, right? Oh, because velocity is positive. As velocity is positive, direction is positive. I'm just gonna restart the button. Because displacement, it has to be this one or this one. If it has time, then it's the second one. So displacement is what we're trying to find. Displacement equals 0 plus 1/2. It doesn't say what acceleration is. Okay, what? Unless we use 2 of them. Oh, okay, we do use 2 of them. Okay, so velocity is 8 equals AT, so 23. So 8 divided by 23 is the velocity. Okay. Okay. So that is the velocity. So velocity. So displacement 1/2 a, which is that number, t squared. So times 2. Displacement is equal to that. Okay, so I'm just put it in. 23 squared, 92. Booyah. Right. Oh my god, I actually understand it now. I'll go like teach my friends during like lunch tomorrow. I feel so confident now. Okay. Khan Academy is the god of physics. Anyways, student drops ball from a height of 15. DGS. DGC. Alright. A student drops a ball from a height of 15 meters. The acceleration of the ball is 9.8. Okay, so it has to have time in it, and it does have displacement as well. So it has to be a second. Acceleration. Okay, so it does tell acceleration. So 15 equals VOT, which I assume is 0. No, anyways. 1/2 9.8 t squared. So 15 times 2 was 30. Divided by 9.8. Divide by 9.8. And then you square root that. So 1 point. Actually, I don't know about this one. Alright. An object is moving in 1 dimension. I'm actually so excited now. I actually can do physics now, guys. It's like monumental. An object is moving in 1 dimension. The position of the object as a function of time is modeled mathematically by the equation. Acceleration of the object. So this looks the most like, oh god, I would say it looks the most like this one, but it's not necessarily. Okay, so 5 is acceleration. Nope. Acceleration speed is increased. And acceleration is 0. That's not true. Average velocity is 10. No, that's the initial velocity. Okay. Acceleration 0. Oh, oops. That is that one. Okay. So they always use that formula. Alright, let's see. It's from an uphill ramp with initial velocity of 4 meters per second, constant acceleration of negative, and his speed is decreasing. Oh, yeah, these two kinematics again. Alright, let's see. So it has time and not position. So velocity, initial velocity. No, it's decreasing. Positive. But velocity is negative. Why are you kidding me right now? Are you kidding me right now? How is it increasing? Alright. No. What? Okay, got the velocity part. What? Acceleration is negative. Since the velocity and so. Oh. Let me write that down. Oops. You know what? I just love Khan Academy. I even have a notebook with Khan Academy logo on it. Anyway, if womp womp. A dog is at rest. He sees a squirrel and runs after it. After gaining speed for 40 seconds, how fast did the dog run? Alright, so that will be time and velocity, but 40 seconds. Alright, so it should be first kilometer. Initially at rest, and then final velocity, gaining speed. Oh, but that's acceleration. That's acceleration. Okay, how far did it augment? Oh, that is displacement. Oh, you're right. That's displacement. Displacement and time would be x equals 0, 0. Delta x equals 1/2. Acceleration is 2.3. Then 4 squared. $18.4. You know what? I feel so confident. I mean, I'm gonna film like a tutorial now because I just feel confident. Alright, let's go. Let's see. Okay, imagine if I get it wrong. Okay. So in this problem, you see displacement and acceleration and time. So it will be either these two. And if it has displacement, then you have to use this one. Alright, hold on. Okay, so x minus x initial, just displacement is just 12. And then tell us the initial velocity. Oh, stationary both. Sorry. Okay, so 0 plus 1/2. Acceleration is 0.8, and then time, which is what you're trying to find. So what I do here, cancel that out, multiply it here. That's 24 equals to 0.80 t squared. So we divide that by 0.8. So that's 30. So square root of 30. Which is 5.5. Let's see. Imagine it's wrong. Okay. Yes. Done with my tutorial. do here, cancel that out, multiply here. That's 24 equals to 0.80 t squared. So we divide that by 2.8. So that's 30. So square root of 30. Which is 5, 2.8. So that's 30. So square root of 30. Which is 5.5. KGC. Let's see. No, it's wrong. Yes. So I. So that. Which is 5.5. Which is 5.5. Let's see. No, it's wrong. Yes. So x minus initial, which is space and then just. Stationary mode, sorry. Okay, that's 0 plus 1 half. Acceleration is 0.8 in time, which is what you're trying to. So what you do here, cancel that out, multiply here. That's 24 equals to 0.80 t squared. So divide that by 2.8. see. Not in trouble. Yes. So there's no problem. You see this. Yes. So in this problem, you see. Oh, my battery's at 3%. That's suboptimal. Okay. So, acceleration 3. Speeding up. Okay. Oh, I'm not falling for that one again. I think so. Yes. Bum, 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 bum. Let me go random. Let me ask ChatGPT. Oh, happy Mother's Day, by the way. Right. A spring-loaded plunger pushes against an electronic sensor attached to the car, which is okay. I have 32 minutes left, and then I can get out of here. I mean, I can go to sleep. Anyways, the car is then released and moves along the surface. Oh god. Which of the following graphs should a student use to determine change momentum of a car since without taking any other measurements? Okay, so you have time. Oh yeah, all of them are a function of time. Yeah. Measures of force, the position, velocity, and change in momentum. is gym pulse. Is L. Momentum. MV should be this one. What's angular momentum? Is it? Did it say angular? Oh, it just says momentum. Bro, are you kidding right now? It is that one. But what is P over M? Precision. Oh. Acceleration. Alright, whatever. Momentum is the sum of forces. And force is 0. Alright. Force. Oh, over change in time. Okay. So that's 3 over 7. Alright, positive. Okay. Okay, negative. Oh, because it went boundary. Yeah, okay. Okay, because it. Yeah, okay, that makes sense. Okay. When ignited in model rockets, there's a thrust. Okay. 22.5. Gym pulse. Actually, I skipped around. I should probably go back to unit 1. Yeah. I should go back to, you know what, I'll just finish this one. Okay. Momentum in time graph. PT, FT, PT, PT, FT equals FT equals P. So P divided by T is force. Speed. That'd be negative first. Yeah. It should be somewhat like that. No, then it has to be this one. Alright. Yeah, no, I'm going. Yeah, I shouldn't skip. Let's see. Motion 1. Car is stopped at a traffic light. When the lights turn to green at time of 0, truck with constant speed has the car and the car is moving under uniform acceleration. Okay, this one's good. Where did my physics stuff go? How long would it take for the car to catch up the truck? So that's 50. And that's 25. And that's 100. That's 100, and that's not 100. And when that's 15, that would be 150. But that would not be 150, that would be 170. 27 times 15 divided by 2 is 200. So it should be whenever the area should be the same. There we go. When it's 19. Is it say nearest 10th? Two significant figures. 12. Worth. Yeah, that's right. Tasting of charger. Alright. Oh, I'm so tired. I can't. Oh, wait, what? What is acceleration of the car? Okay. So change in position is 2 over change in time is 4. So velocity, change in velocity over change in time. So the velocity when it's there. But that is change in velocity, right? Or is that average velocity? Average velocity. Not sure about this one. Is it? Oh, wait, one. That's interesting. 7, 8. 1 over 1. So that's 1. But there it's. It's like 0. It's either like 1/4 or 1/4 or 1/8 either, but I don't know which one to use. I mean, I don't know which one is like, yeah. I mean, I don't know how they find the velocity of that. Oh, they will look for acceleration. Oh, okay. Oh, I'll keep going tomorrow. So we can use the kinematic equation. position graph would look like that. But that's not what a velocity would be decreasing. Does it start at... That's definitely not the same velocity. Oh, acceleration? No. Same position at T. No, that's not it. The magnitude of acceleration of A is larger than the magnitude of acceleration of B. Okay, no. Wait. No, magnitude is not how direction. Farther. No. Goodbye for now. I have 10 minutes. I'm just gonna go.
an office plan.
Miller just lobbed a message way over Jones's head using some technical jargon.
Let's see if they can use Grammarly.
Alright, this is going to be a review video of all the top topics on the AP Physics 1 exam, starting with the kinematic formulas. Here they are. You get 3 kinematic formulas. These 3 formulas relate 5 different kinematic variables. What are those variables? Well, one of them is time. You see here and here and here. This is the time it took. It's really like a delta T. Time it took to go from some initial position to some final position. That's what we mean by time. So effectively, we're considering T at the beginning to be 0. We start our clock right when the motion begins. But we don't necessarily do that with the position. The initial position might not necessarily be 0. Maybe this starts at like x equals 50 or something, but whatever that is, that's your initial position. X is your final position. Why don't they write final? I don't know. You just got to know that X without a 0 on it means final position. And you might be like, final position? Does that mean like the very end of the process? No, not necessarily. If your guy got thrown up over here, he's free falling up, and then he comes back down, you might be like, oh, X final, that's got to be down here, because that's when the problem ends. No, it doesn't have to be. You can choose that as X final, but you could also choose this as X final. It's like, why would you do that? Well, maybe you want to know the time it took to go the whole way. Well, if I want to know this entire time, then I'd probably want to choose the end of my analysis to be down here. That'd be X final. It'd probably be Y final, vertical is Y. You'd probably call it Y final. Maybe I didn't want to find that. Maybe I wanted to find, hey, what's the time it took to get to the top? In which case I might be like, well, then I want to choose the end of my analysis to be up here. If I choose this location as Y final or X final, then the time that I would solve for in my formula, or that I would plug in, either one, would be the time it took just to get to the top. So depending on what you're looking for, choose X final to be wherever's convenient for you to solve for the thing you want to solve for. It doesn't have to be like, when the universe ends, where's this object? It doesn't have to be the end of the problem. It can be wherever you want. And if you choose, whatever point you choose as X final, there's going to be a final velocity. This V right here is the final velocity again. It doesn't mean like, when the universe ends, what's the final velocity? It means at the point of analysis that you're looking at, what's the velocity at that X final? And you've got a V initial over here. This is, again, similarly, the initial velocity it had at the beginning of your analysis. And then you've got an acceleration. The acceleration right here is the most important variable. I'll tell you why in a minute. This acceleration, points right if it's speeding an object up, moving to the right, but it could point left as well. It could point left on an object moving to the right if it's slowing it down. So you might be like, oh, it's negative if it's slowing it down. Well, yeah, it can be negative if it's slowing it down, but it doesn't have to be. Consider this guy free falling. The acceleration due to free fall is acceleration due to gravity, negative 9.8, but on the AP exam, you're going to use negative 10. That's very nice of them. This makes the numbers come out nice. You're going to use negative 10 for your acceleration due to gravity, and it's constant on the way up, at the top, and on the way down. So acceleration is negative 10 all the way to the top. You might be like, wait, at the top, isn't the acceleration 0? No, the final velocity is 0 at the top. But the acceleration is not 0 at the top. It's negative 10 the entire way, on the way up and on the way down. And so look at what happened. On the way up, I was slowing down and I had negative acceleration. And that makes sense. Negative acceleration, slowing down. But on the way down, I was speeding up. And I had negative acceleration because it was negative the whole way. How can I be speeding up and have negative acceleration? Well, it's because my velocity was negative and my acceleration was negative on the way down. And if you ever have that case, if the acceleration and velocity ever point in the same direction, you're going to be speeding up, even if they're both negative. So you got to be careful. They'll try to... So the center of mass is a location within some mass distribution. So say you had a 6 kilogram mass and a 2 kilogram mass. If you found the location of the center mass, that would tell you where the system would balance. In other words, if I just connect this 6 kilogram to the 2 kilogram with a very light rod that has no mass itself, the location of the center mass would tell you exactly where it balances. So wherever this would balance, the pivot or fulcrum, sometimes it's called, is where the center mass would be. And it has to be proportionally closer to the larger mass. So since this 6 kilogram mass is 3 times bigger than this 2 kilogram mass, the center mass has to be 3 times closer. So if this is 16 meters, so the center of mass is a location within some mass distribution. So say you had a 6 kilogram mass and a 2 kilogram mass. If you found the location of the center mass, that would tell you where the system would balance. In other words, if I just connect this 6 kilogram to the 2 kilogram with a very light rod that has no mass the location of the center mass would tell you exactly where it balances. So wherever this would balance, the pivot or fulcrum, sometimes it's called, is where the center mass would be. And it has to be proportionally closer to the larger mass. So since this 6 kilogram mass is 3 times bigger than this 2 kilogram mass, the center mass has to be 3 times closer. So if this is 16 meters, and this is 4 meters, 4 meters, 4 meters, 4 meters, the center mass would have to be right here, because that way I'm 4 meters from the 6, and I'm 12 meters from the 2, and 12 is 3 times bigger than 4, and so the 6 is 3 times closer to the center of mass. So let's prove it though. Let's say you didn't have numbers that were that nice. You wanted to prove the center mass was right here. There's a formula. You get this on the formula sheet. It's x center of mass is the sum of all the m times x's over the sum of all the m's. What does that mean? It means pick all the masses. So, and choose a place to measure from. You might be like, where do I measure x from? Well, you get to pick. So I'll just pick the left-hand side. I like picking the leftist-most mass as x equals 0. All of our x's are going to be measured from there. So if you use this formula, it's like, okay, let's add them all up. 6 times, well, where's the 6? It's at 0. It's at x equals 0 plus 2 times, how far is it? It's 16 away from x equals 0. So 16 divided by the total mass would be 6.2 is 8. And if you multiply that all out, look what you get, 4 meters, which is exactly what we found. 4 meters from the point we were measuring x equals 0 from, which is exactly there. You could have chose this side. If you did that, you would have got like 12 or negative 12, which tells you, oh, it's 12 from there. So you can choose x equals 0 wherever you want and be consistent. It'll number, external force times time, gives you the change in the electrical system. If you have no external forces, then there will be no change in the velocity of the center mass. So if you can only change momentum, total momentum, by external forces, and you have none of those, then you're not going to be able to change the velocity of the center mass. What does that mean? It means after these collide, they come in, right? And they collide. Those are internal forces. This center mass is going to keep chugging right here, keep on trucking at exactly 2 meters per second after these collide and head out, because that was an internal collision. Only some third mass, right, causing some external force could cause this center mass to go faster or slower or deviate from its path. Only external forces can affect the motion of the center of mass. So the angular kinematic formulas look just